This is objective 1 of 6, using a potentiometer value to tell whether the LED should turn on or off based on the range of where the potentiometer is. In this case, we're using an if statement to tell the potentiometer to tell the LED to turn on when the potentiometer goes above a value of 400. When the potentiometer is below a value of 400, it kicks out of that if statement and goes to the else statement, which leaves the LED off. So you can see here I'm at 0 now. As I slowly approach 400, the LED kicks on and it'll stay on forever as long as I keep it above 400. We can turn it back down below 400 and the LED turns off. This is objective 2 of 6, using the line tracker in order to tell the serial monitor, or display with the serial monitor, what line or what color line is underneath it, black, white, or no line. You have the positive and ground powering the light sensor, and then the signal coming from the white wire going into digital pin 5. Now we can go over and look at the serial monitor. As you can see, right now it's displaying as no line detected. That's because I'm holding it up in the air. Now if we set it on the table, you'll get a white line detected because there's a white piece of paper on the table. And then my laptop has a black surface on it, so if I set it on that, you'll get a black line detected. And then we go back into the air, and it's back to no line detected. This is objective 3 of 6, demonstrating that when you press either or of the buttons, the yellow LED will turn on, but when you press both of the buttons, the red LED turns on instead. And neither of the buttons, they're all off. This is all using digital inputs and outputs. The red and yellow LEDs coming from the 2 and 3 digital pins. And the buttons, although they are color-coded with colors, don't really matter what color they go to because they're going to the LED based on the state of the buttons together. But they are going into digital pins 11 and 12. This is showing objective 4 of 6. The wires coming from the digital pins as inputs are going into their corresponding buttons according to color. Coming from the ground, because they are pull up buttons, we have them set in the code to be opposite, so the lights will turn on when they are closed, not open. They are running through the Arduino, through the code, and coming back out through output pins into these 3 LEDs corresponding with the colors of the buttons. So when we press the red button, the red comes on. The green button, the green comes on. The blue button, the blue comes on. But if we when we don't press anything, they turn off. And when we press any combination, they also turn off. This is objective 5. You have the power coming from 5 volts going into the positive bus, ground coming out of the negative bus going back into the ground pin. The wires are color-coded according to the button they are going from to the color they display on the LED. The LED is set up as it is shown in the wiring diagram that is provided with it. And as you can see, when we press the red button, red light comes on, green light comes on, turning off in between each one. blue, and blue light comes on. And then any combination of the three. Red and green makes yellow. Green and blue makes cyan. All the different colors. And then red and blue make magenta. This is the last objective, 6 of 6, using the photoresistor to turn a bank of 6 LEDs on. The way the photoresistor is set up is it's set up in a parallel circuit with a 10 kilo ohm resistor, taking it to ground for balancing, and then the signal coming from it going into analog pin 2, and the threshold is set to 900, which is the analog value from 0 to 1023 coming in from the photoresistor. And if I turn on the flashlight on my phone, then the LEDs remain off. Then when I pull the flashlight away, it drops below that value, and the bank of LEDs comes on.